And now, the testing procedure for the hydrogel sample.
Secure the transparent wall onto the sample holder. This can be done directly on the mechanical tester, but be careful not to touch the load cell or the indenter. Otherwise, this can be done by removing the sample holder from the testing chamber. Note that applying a small amount of water to the inside wall and the O-ring will ease the installation. If the sample holder has been removed from the testing chamber, screw it back onto it. Now, using manual controls, lower the stage at medium speed to approximately 20 millimeters above the sample holder, and at low speed to approximately 2 millimeters above the sample holder. If the sample holder has been removed from the testing chamber previously, we will need to find the vertical position of the bottom platen once more and set it as a reference by performing the following test sequence. A zero load, we will not save the data, followed by a find contact with the position Z as the stage axis in the positive direction with a velocity of 0.01 millimeter per second, a contact criteria of 0.3 Newton, and a stage limit of 3 millimeters with a stage repositioning of 2 times the load cell resolution. Then we will insert a zero position function with the position Z as a stage axis parameter. We can execute the sequence. Now, using the manual controls, raise the stage at least 50 millimeters above the sample holder. Then place the disc-shaped hydrogel sample in the center of the sample holder using tweezers and using the cross at the center of the sample holder as a guide. Now, using manual controls, lower the stage at medium speed to approximately 20 millimeters above the sample and at low speed to approximately 2 millimeters above the sample. Now perform the following test sequence to measure the disc thickness. A zero load, followed by a find contact with position Z as a stage axis in the positive direction and a velocity of 0.1 millimeter per second, a contact criteria of 0.3 Newton, stage limit of 3 millimeters, and a stage repositioning of 2 times the load cell resolution. We can now execute the sequence and report the current position of the vertical stage axis as the thickness of the hydrogel sample. Now fill the chamber with deionized water. And now proceed with the torsional shear test using the following sequence. A zero load as the first function, since we just poured deionized water in the chamber. A stress relaxation function, which corresponds to a pre-compression of the sample using the position Z as a stage axis and the force in the Z direction as the load cell axis.
A ramp amplitude of 10% of the sample thickness, which corresponds to 0.3965 millimeter.
A ramp velocity of 0.4% of the sample's thickness per second, which corresponds to 0.015858 millimeter per second. We will perform one ramp, which will stop based on the relaxation rate. We will save the data as group number underscore team number underscore torsion underscore hydrogel. Then we will insert 6 sinusoid function using the rotational stage axis with an amplitude of 2 degrees at different frequencies such as 0.01, 0.05, 0.1, 0.5, 1, and 2 Hz. Each sinusoid function will have a number of cycles of 3, and the data will be saved in the same file as the stress relaxation function. Ensure that the low-pass filter is unchecked in the load cell window and press on execute.
So here is the pre-compression of the hydrogel sample. And now the hydrogel is subjected to dynamic angular shear deformation through sinusoid functions.
Now that the torsional shear test is done, using manual controls, raise the stage above the sample holder, unscrew the sample holder from the testing chamber and dispose of its content.